Hey guys, I'm Dimix and today I want to show you my PrintNC build. So people have been asking me to make a video on this, so I'll just show it. So we have a fully sealed enclosure and in that I have my machine. So I'm just going to walk over here and open it up for full dramatic effect. So, I mean, what you can notice right away, the machine is hanging. So there's like multiple or different approaches you can take to remove the chips that build up on top of your workpiece. So you either can suck them away with a vacuum, you blast them away with a compressed airstream, you wash them away with coolant, but then the chips get trapped in the coolant and are washed away, but then you have coolant everywhere. Or you let gravity do the job. And here we're letting gravity do the job for us, and it's working really well. So this area stays like this most of the time. I don't clean this. The chips, they collect on the gantry, they collect on the ball screws. But what I do to clean that is I just use this bicycle brush. I just brush them away from time to time when it gets too bad. I'll further investigate some like approaches to limit the amount of chips that get like thrown or like shot. It's more like they get shot through from the spindle. So I was thinking of just making like kind of an umbrella with magnets, and I just stick it on bottom of the spindle. The chips will be stopped by the umbrella and then just fall down. That's just something I still have to design and make. At the moment this works, so no vacuum, no holes required. So the only holes we made in the box are the ones for the cables, and these are sized perfectly. So I measured the cable and I drilled a hole into the box that has the diameter of the cable. Then I pulled the cable through, and after the fact I soldered the connectors on. So making these connectors, and these are essentially extension cables. So on the one side we have the connector, and then on the other side, like, you can't see. Anyhow, we have the electronics here, and on the back there's all the cables. So there's a big cord of cables coming out of this box, goes into the electronics, and so this box is fully sealed. The holes are minimal. It's actually double sealed, so there's two seals here, and this isolates very well. The machine is not bolted directly to the box. I had a previous China cheap CNC and I bolted it directly to the box. However, the vibrations, especially the low frequency vibrations, for example when you're doing a rapid motion change, like going around a right angle, like you have to stop and then go in the other direction. All of these movements created a lot of vibrations which got transferred through the box. So what we have done here is the machine is essentially floating on like rubber vibration dampers, and at the bottom it's sitting. There's like bigger vibration dampers, so the weight of the machine is resting on the vibration dampers at the bottom, and these dampers are just preventing the entire machine like from tilting over. It's top heavy, so the spindle, my device is getting hot. Let's see how far I get. The spindle is most of the weight. We have a lever, so actually the machine wants to tilt over. This prevents that. I had a few other challenges I had to solve. The default 10 millimeter pitch lead screw ball screws. For why? They were too easy to back drive. So when I would switch off the machine and the steppers would lose power, the gantry would drop down. And at first I thought that's not an issue, but there were a few issues with that. And the easiest fix for me was to change the ball screws, the pitch of the ball screws from 10 millimeter to 5 millimeter. That gave me more torque, but higher acceleration with decreased maximum speed essentially, and the gantry doesn't drop anymore. Other than that, there are a few mods I did to this machine. So these steppers are smaller than the default spec. So these are NEMA 24, and they are basically, the length of them is so it doesn't stick out of, I chose the length of the motor so it doesn't stick outside the frame. The Z-axis motor is inverted, like flipped, just like the Y-axis motor. So there's basically just a belt, motor is flipped to the other side. Otherwise this motor would stick, it would stick outside the box, or I would have to make the machine smaller. And I wanted to have the largest machine that fits within this box. I made this box already, and it was a lot of work. I had to do like a lot of just research into vibration damping. Like this box is a triple layer box. So there's one sheet of MDF, then there's a sheet of I can show you. It's this material. It's essentially cardboard with fine sand, and this is amazing for the high frequency vibrations. Like the sand is able to absorb all the high frequency noise. So spindle noise, 0. High frequency fan noise, 0. The only thing that this doesn't damp is low frequency stuff. And I found that low frequency things, low frequency vibrations are like almost impossible to dampen. For example, music, if you listen to loud music, the bass, it just travels through the walls and there's nothing you can really do about it. But the annoying noise is high frequency. So spindle, screeching, cutting, all of that is like greatly reduced with this box. So this setup is so quiet that sometimes I use this machine at midnight. Like in the middle of the night I can use this machine. Like I get home from the lab, I design some parts and I'm like finished at 10 p.m. to program them, and I just mill for another 2 hours. So for me, this is amazing. Other than that, what else can I say? The drag chains are mounted within the frame. So I designed some mounts. I don't know how they're mounted usually. I just mounted them in a way so that they're within the frame. Yeah, I mean, we have a probe. The spindle is grounded, so usually when I probe, I just use, when I do aluminum, I just put the clip on the part. It's nothing too fancy. We have a camera. So this mount is from a dial gauge. This is a really nice mount. Like you can move it into any position, tighten it down. It wobbles a little bit, but it's fine. So I have a dedicated screen so that I see the camera. This is a 1080p camera, and I also record the videos sometimes. Then I have a laptop here. It's on an arm, like a display arm, so when I'm standing, I can move it up. When I'm like at the machine and I'm like just messing around, I can move this down. And at the side we just have a magnet like strip, and I mount, like I keep the tools here, like the tools to open the collet clamp. This machine, the box is sized to be very similar to a washing machine. I did that so that I could use like moving harnesses from washing machines. There's like harnesses where you can carry a washing machine with 2 people, because this box weighs a lot. This box weighs 80 kilos and it's almost like a stone. It's so heavy that when you move it, it doesn't do anything. Another benefit of having a box that is the size of like a household washing machine is that there's things, for example, like this setup here is a telescopic like base for a washing machine. It has the wheels, and you can tighten those feet so it doesn't rest on the wheels. At first I wanted to design something myself, and then for some reason, like, I was just looking for these caster wheels, and I found this telescopic base, and then I realized this has everything I need, and all I needed to do was lift the box up, put it on this base, and good to go. So let's see what else.